Okay, let's learn intake and exhaust valves, design in GT power, and their performance. In a combustion engine, the intake valve allows fresh air or air-fuel mixture to enter the cylinder, while the exhaust valve allows burnt gases to exit. These two valves control the breathing of the engine, and breathing determines power, efficiency, and emissions. So, what is the function of intake and exhaust valves? As you can see in this picture, we have intake valve, and the function of intake valve is at first opens during the intake stroke and allows fresh charge into the cylinder. Yeah, intake valve absolutely has larger diameter than exhaust valve and operates at lower temperature. And about exhaust valve, opens during exhaust stroke and releases high temperature combustion gases. And absolutely, exhaust valve has a smaller diameter, expose too much higher thermal stress. The exhaust valve typically operates at temperature up to 700 to 900 degrees, while the intake valve runs much cooler. But why the intake valve has larger diameter than exhaust valve? Or why it has larger diameter than exhaust valve? Because intake needs more flow area. And in high performance engines, this ratio may increase further. What is valve lift? It means maximum distance the valve moves away from its seat and is controlled by cam profile. And absolutely increasing lift may lead to better high RPM breathing, high speed actual breathing, and higher mechanical stress and more friction losses. How about increasing intake diameter and exhaust diameter? Increasing intake diameter can lead to improving volumetric efficiency, and that can increases power and may reduce air velocity at low RPM, low speed. What about increasing exhaust diameter? It can improve scavenging. It reduces pumping losses, and large exhaust valve reduces compression ratio, has less seating area. And as I said about increasing valve lift, it can lead to better high RPM breathing, higher mechanical stress, more friction losses. So let's go through designing valves in GT power. Okay, how valves are modeled in GT power? Here we have valve intake valves, 2 intake valves, and 2 exhaust valves. You can import the valve from connections, valve cam connection, okay. Here we have many features about cam timing angle. This parameter defines the angular position of the cam event relative to crankshaft rotation, and it determines when the valve starts opening, when it reaches maximum lift, when it closes. Cam timing anchor reference. This defines the reference point used to position the cam timing event. It tells the GT power from which crank angle should the lift profile be aligned. And common references are TDC firing, let's see, TDC gas exchange, or BDC. Incorrect anchor reference can shift the entire valve event and produce unrealistic combustion behavior. And about cam timing lift area reference, this specifies which lift profile dataset is being used. How about lift profile? Valve lash is a mechanical clearance between valve stem tip and rocker arm or cam follower. In GT power, lash affects effective opening timing, effective closing timing, and initial lift ramp. If lash increases, valve opens later and closes earlier, and effective duration decreases. And too little lash may cause not fully sitting, valve not fully sitting, and compression loss, thermal damage. Valve profile dependency object uses when modeling variable valve lift, VVL, variable valve timing, VVT, and multicam strategies. It allows the valve lift curve to change depending on engine speed, load, control signal. At maximum lift, this parameter defines how long the valve remains at maximum lift. An angle multiplier, this scales the crank angle duration of the cam profile. If this is bigger than 1, can lead to longer duration, and smaller than 1 can lead to shorter duration. Main parameter in flow coefficient is valve reference diameter. This is the reference diameter used for normalizing flow area. We have discharge coefficient reference area definition. This defines which area is used when calculating discharge coefficient. And about flow coefficient lift unit, defines the lift unit used in the lift table. For example, millimeter, inches. And the output part, for example, valve event lift flag, determines how valve timing is defined based on zero lift, based on reporting lift threshold. Or about closing valve event reporting height, valve is considered closed when lift drops below this threshold. An opening valve event reporting height defines the lift valve at which GT power considers valve is officially open. For example, if set to 0.1 millimeter, opening timing is reported when lift exceeds